Hello and welcome to the 6.1 E-Day Notes. Here we go. Today it's basically based off this chart. We're going to go a little bit less in depth than what we normally would, but basically we've got 4 special lines inside of a triangle, and these 4 special lines are used to create 4 special points. And here we go. Let's go through the chart. The first one is the perpendicular bisector. You notice that this line right here inside this triangle is perpendicular to a side, meaning it makes a right angle and it bisects one of these sides. So therefore it is a perpendicular bisector. When you draw another perpendicular bisector, so let's say that I drew another one. So I went over to this side and I put a midpoint and I made a perpendicular line. These intersect at a special point. That special point is called the circumcenter. The circumcenter. How do you find a circumcenter? You have to make 2 perpendicular bisectors. So if you make 2 perpendicular bisectors, you get a circumcenter. The circumcenter ends up, here's a picture of one, if I do. The circumcenter is special inside of the circle because it is equidistant to the vertices. So if I go from the circumcenter, the distance to A, B, and C are all the same. What that allows me to do is to draw a circle around the triangle, and that's called a circumscribed circle. A circumscribed circle goes around the triangle. Alright, so here we go. Perpendicular bisector. If you draw 2 of them, you make a circumcenter. The circumcenter is equidistant to these points, the vertices of the triangle, which allows you to draw a circumscribed circle. The incenter, angle bisector. Let's go to the angle bisector. Pretty obvious here. If you take an angle of a triangle and you cut it in half so that this side is the same as that side, that's called an angle bisector. If you do it again, if you take this angle and you bisect it, they meet at a special point. That special point is called the incenter. The incenter is special because it is equidistant from the sides of the triangle. The circumcenter is equidistant from the vertices. The incenter is equidistant from the sides. So here's an example of one right here. We can show equidistance by going to the sides. And because it's equidistant to each side, you can draw a circle that's on the inside of the triangle. And that is called an inscribed circle. So the circumcenter makes a circumscribed circle, and the incenter makes an inscribed circle. Alright, so there's that. The median. A median is like a perpendicular bisector. It bisects a side, but instead the perpendicular bisector has a right angle. This one just goes straight to the vertex. And if I made another one of those, so if I went in here and did another midpoint and went straight to the opposite vertex, I get a special point called a centroid. So how do you find a centroid? You make 2 medians. So this is related this way. How do you make a centroid? You make 2 medians. Alright, what's special about the centroid? Turns out the centroid is the balancing point. It's the balancing point of the triangle. I could put my pen there and I could spin the triangle it's like the center of mass. If we were in physics, we'd call it the center of mass. Also, turns out that the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. What that means is, if you take a median, this length will be x, and the larger one is twice as big, and the total length, therefore, is 3x's. So you got x, 2x, and 3x. So this larger piece is 2/3, the smaller piece is 1/3, the entire length, think of it as thirds, 3/3, and the smaller piece is half of the larger piece. The last special segment is called an altitude. An altitude just starts at a vertex, and it's just, you go straight down at a right angle, and that's an altitude. If you do it with this vertex, if you start at this vertex and go straight at a right angle, they make a special point called an orthocenter. And the orthocenter, there's really nothing special about an orthocenter. Alright, that's how it goes. So, in summary, you've got perpendicular bisectors. So if you bisect the side, you go to a midpoint and draw a perpendicular line. You go to a midpoint and draw a perpendicular line. You go to a midpoint and make a perpendicular line. You make a circumcenter. A circumcenter is equidistant to the vertices and allows you to draw a circumscribed circle. I'll be down in 5 minutes. Give me 5 minutes.
No, that was going to take forever.
No, it's going to take 5 minutes. Go downstairs. Go on. I'll be down in 5 minutes. The angle bisector, if I take this and cut that angle, and I take this and cut that angle, and I take this, cut that angle, I get an incenter. And an incenter is equidistant to the sides, which allows me to draw an inscribed circle. It's a very bad circle, but there it is. A median goes from a midpoint to a vertex, midpoint to vertex, midpoint to vertex, makes a centroid, and the centroid splits up these pieces. First of all, it's a balancing point, and if this was 4, that makes this length 8. That's how that works. And if this was 6, that makes this length 12. And if this was 6, that would make this length 3. The smaller piece is half of the larger part. And then lastly is the altitudes. If I start at a vertex and go at a right angle to the side, vertex, right angle to side, vertex, right angle to side, I get an orthocenter, and that's everything in a nutshell there. Alright, so that's all the info. Maybe you need to watch this again, but there's 4 points, there's 4 special segments, 4 special segments, 4 points. Each point has a special property, except for the orthocenter doesn't really have a property. Alright, so 4 segments, 4 points, 3 special properties. You need to know those to get through the rest of the lesson, or the homework, I guess. Alright, have fun. Bye-bye.